All right, welcome everyone. So picture this. You've spent ages training a killer machine learning model. It's working perfectly on your laptop. But now what? That's the big question. Today, we're going to take that brilliant model out of the lab and put it into the real world. Let's dive in.
You know, this is the exact spot where so many data scientists and ML engineers get stuck. The model is solid, the accuracy is great, but how do you actually let anyone use it? How does it stop being just a file on your computer and become something more?
And that right there, that's the heart of the problem. All that potential, all that amazing predictive power is just locked away. It can't power a feature in your company's app. Your colleagues can't use it. It can't make any real impact. It's basically an island, totally cut off from everything.
So, our goal today is to build that bridge. We're going to take that static model file and turn it into a dynamic, living service that anyone or any application can talk to. And the way we do that, we build an API.
Okay, so what exactly is an API? Well, API stands for Application Programming Interface, but think of it like this. It's basically a contract. It's a clear set of rules that lets different pieces of software talk to each other. For what we're doing, it's the front door to our model's brain.
But why bother with all this? Well, because an API is what turns your model into a reusable service. It's what lets your web app or mobile app send some data and get a prediction back, like instantly. It lets your model become this standalone piece that you can just plug in to bigger, more complicated systems. This whole approach makes everything way more modular and lets you scale up to handle tons of requests. Honestly, it's the language of modern software. Now, when you're building APIs in Python, you're going to hear two names pop up over and over again, Flask and FastAPI. You can think of them as two different approaches to solving the same problem. And choosing the right one really comes down to what you care about most, good old-fashioned simplicity or raw modern performance.
So Flask is the veteran, right? It's tried and true, super simple, and really flexible. It's awesome for getting a basic API up and running in no time. Then you've got FastAPI. It's the newer, high-performance challenger, built from the ground up for pure speed and packed with features you really need for production systems. And this is where things get really interesting, because this chart lays out the trade-offs perfectly. Look, Flask is the clear winner on pure out-of-the-box simplicity, 5 stars. But then, look at FastAPI. It comes loaded with stuff you'd have to bolt on yourself in Flask. We're talking built-in support for async code, which is just a fancy way of saying it can handle a ton of requests at once without breaking a sweat. Plus, automatic documentation and data validation for free. These are absolute game changers for building solid, reliable apps.
And here it is, the headline feature, speed. Seriously, FastAPI is one of the fastest Python frameworks out there, period. It's up there with languages like Go and Node.js, so if you're building something that needs to handle a huge volume of requests with almost no delay, think real-time fraud detection or something like that, this performance difference isn't just nice to have, it's a total game changer.
All right, enough with the theory. Let's get our hands dirty and see what this actually looks like in practice. What does the code look like? We're going to check out a simple blueprint for both Flask and FastAPI to really see them side by side. Okay, so with Flask, it's pretty straightforward. You import a few things, load up your model file, probably using something like Pickle, and then you define a route or an endpoint. The key thing here is that you have to manually grab the data from the request and then send back your prediction. It's simple, it's linear, but you're doing all the work yourself, including checking if the data you got even makes sense. Now contrast that with FastAPI. This is where the magic happens. You use these things called type hints to just declare what your input data should look like. You know, age should be an integer, that kind of thing. And just from that, FastAPI does two huge things for you automatically. First, it validates all the incoming data to make sure it's correct. Second, it generates interactive API docs for you, for free. You still load your model, maybe with something a bit more modern like joblib, but you get so much more power and safety for way less code. Okay, so having working code is great, but it's not the end of the road, not even close. To run this thing reliably anywhere, in the cloud, on another server, wherever, we need to package it all up. We need a consistent, reproducible little box. And to do that, we need to talk about project structure and a tool called Docker.
Look, a clean project structure is absolutely non-negotiable for any real-world project. Here's a super standard layout. You've got your AppPy, that's our API code. Model.pkl, that's our trained model. Requirements.txt, That's just a list of all the Python libraries our project needs. And finally, the Docker file. Think of that as the recipe for building our self-contained application.
Now, this Docker file might look a little scary at first, but it's really just a series of simple instructions. Step 1, we start with a clean Python environment. Step 2, we copy in that list of libraries we need. Step 3, we tell it to install them. Step 4, we copy in the rest of our app code. And the final step, we tell Docker what command to run to actually start our API server. For something modern like FastAPI, you'd use a super fast server called Unicorn. And boom! This creates that self-contained box that will run the exact same way on your laptop as it does in the cloud. No more "it works on my machine" problems.
Okay, we've got a working, containerized API. Awesome! But now we're going to talk about what separates the good APIs from the great ones. Let's go over some pro tips that will make your service rock solid and the common mistakes you absolutely have to avoid.
These right here are the habits of pro ML engineers. First off, keep your training code and your API code separate. Trust me. Next, use config files. Don't hard-code things like file paths directly in your code. Super important. Add a little /health endpoint. It's just a simple page that says, "I'm alive," so monitoring systems know your app is running. And please, please, track your model version in the API's response. It will save you from so many headaches down the line when you have to debug which version of a model made a weird prediction.
And on the flip side, here are the things you should never do. Seriously, never, ever, ever use a Jupyter Notebook to run a production model. It's just not built for it. Always, always validate your inputs. FastAPI gives you a huge head start here, but it's a critical mindset to have. And yeah, forgetting to run enough workers, not having monitoring, all these things are recipes for disaster when you're running in production.
So let's just zoom out for a second and look at the journey we've been on. We started with an experiment, an idea, totally trapped inside a notebook. But by wrapping it in an API and putting it in a container, we've completely unlocked its potential.
And this really just says it all, doesn't it? Models inside notebooks are just experiments. It's the API that turns them into real products. It's that final, crucial step that transforms a piece of research into something valuable that can plug into the rest of the world and actually make an impact.
So the question really goes back to you now. You've got the model, and now you've got the blueprint to turn it into a real live service. Maybe it's a fraud detector, a recommendation engine, a chatbot. The possibilities are literally endless. So what are you going to build?